Tech Nuggets, IPv6 intro. We're going to talk a little about IPv6 and why do we need it. What's the basic gist of what's going on? There's a lot of conflicting discussions and online posts, very passionate on both sides of the issue. Why is this necessary? And then we'll go on to a practical demo where I'll do some basic Voios configurations with a v6 network, and we'll talk about how to put IP addresses in, just kind of the basics of configuring an interface and that kind of stuff. There'll be additional tech nuggets in the future that will cover more advanced parts of the ecosystem that goes with IPv6. But for this, we're just going to kind of cover the basics. V6, and the basic gist is we've run out of IPv4 addresses, and lots of people talk about, well, that's not a big deal, we can NAT, or we can do this, or we can do that, and especially in the United States, we don't really feel the pain in the United States. Most of the foreign countries in the world really struggle with lack of IP addresses and have been forced to either NAT heavily, which kills their performance, or to do IPv6. They might even be doing dual stack, which is IPv4 and IPv6, where they're NATing on one side of v4 and doing pure v6. The truth is, in the core of the internet, you can't NAT. It just kills the performance. There's too much traffic and too much data to be doing the packet rewrites that go with NATing, and it's just not practical. It kills it bad. So we'll be seeing more and more v6 as we go along throughout careers moving here forward. And again, I've heard this for a long time, but if one is paying attention and reading the documentation and looking between the lines, we're starting to see it creep in more and more. Oftentimes, the discussion that starts with this is very frustrating because different network experts of different ages get very passionate on either side of this discussion. They either don't understand it completely, or they understand it thoroughly and can't understand why we all haven't moved to it. And that creates some very interesting waters when you're just trying to understand what the basic deal is. On one side, you'll hear, well, it's just the same thing. It's just more bits in your IP address. It's no big deal. And at the very basic level, and honestly, a lot of what we're going to see today in the practical demo, that's absolutely true. We're going to see more bits in an address. So that means instead of base 10 numbers, we're going to go to hexadecimal numbers. They're base 16 to make it easier to see. But the truth is, even when we do that, there'll be so many of them that it will be very difficult to understand exactly which IP address. We're talking about networks that have thousands, hundreds of thousands of addresses in them, and we sort of casually drop them like they're just flower petals and it's no big deal. This is very different than our ecosystem in v4, where we're picking and choosing every single IP address very carefully. That's not true with v6. There's so much network address space and host address space that we can be a good bit more cavalier, let's say, about how we hand that out. The truth is that with these v6 addresses, it's not so much the address that's different, but the ecosystem that it lives in. In v4, we might have DHCP that goes and hands out v4 addresses to clients. And while we have something in v6 called DHCP v6, it doesn't fill that exact same role. It is similar, but it's not the same thing. And that can be very frustrating. In many ways, it would be better if we had just created new acronyms or new terms for v6 in order to be able to compare and contrast them more easily. We're not going to get into a lot of that ecosystem stuff in this particular Tech Nugget, but we may examine different pieces of it in future Tech Nuggets. So on to the practical demo. All right, so I've gone ahead and created in GNS3 our basic setup, right? It's a cloud object that has connectivity through the cloud, through my host VM here, out to a network that's enabled with IPv4 and IPv6. Both with public addresses so that we can see a dual stack machine and how to configure it and that kind of stuff. And a bunch of this should be review from when we did IPv4. It's really not that different. And in v6, it's actually still not that different, which is one of the reasons we get the moniker of, oh, it's just more bits in the address. Because basic interface config is pretty much the same thing. Sometimes you have to tell it, route 6 or something like that, but for the most part, it can tell that there's more bits in the address and does it. Especially when we're using colons and not dots, usually the computer's pretty smart about figuring that kind of thing out. And we'll take a real brief look at how my host machine here does it, so we can see it in a GUI. It's set up automatically, but we'll look at an IPA in it as well. All right, so you can see here I've got just a basic, nothing's configured on the machine already, nothing's on the Ethernet cards or anything like that. So we'll just go through the basic, you know, how do I set up ECT kind of deal with v4. There's my gateway, so we'll set up a route. Pay close attention here to how I delineate default route, right? 0.0.0.0, because it'll be different when we do default routes for IPv6. There'll be a different way to do it. So that command will change a little bit, and I'll point it out when we get there. I can ping out. So I've got an IP address, I've got a default route set up, I can ping out. Now I don't have name servers yet, which we'll add here in a second, but it's, you know, they are possible to be had, and we'll add them here in just a second. And then I can do things like that. And you can see I'm using IPv4. Right now the machine's only configured for IPv4, so that's not a problem. All right, so now we're going to set up IPv6, which really is going to use all the same commands. It's really not going to be that different from what we did before. We're just going to use an IPv6 address. Now, there is an assumption here that you've gotten an IPv6 address statically assigned to you from your network administrator or from whoever you're getting addresses from. Whoops. You'll notice I use a colon here, and that's to delineate that everything in between is zeros. So if there were more bytes, there are more bytes in there, it'll blow them all out to be zeros. It keeps you from having to type multiple quads of zeros, because it would be 4 bytes, and so you'd be typing 000 colon 000. It shrinks it all down, makes it a little bit easier to type. These addresses can get quite long, and in most times, unless you're a server or a device that is serving something, you don't have a static. You have effectively a DHCP of some kind address. All right, and so when we go to test this, we're not going to use the standard ping because that's a v4 command. Sometimes, depending on the flavor of operating system you have, you'll use ping-6. Sometimes you'll have a separate command. In our case, we have ping6, which is its own separate command, and we're going to ping our gateway. I hope I typed everything right, because as you can see, there's a ton of little digits to screw up as we go along, which is one reason that it's not super popular to do that. So the other thing you'll notice here is that oftentimes with v4, you can have a convention that says, where's my gateway, where do I put it? In v6, there is a very widely used convention that the first usable address in the range is the router, and that's so that you don't have to type in all the Fs. If you were going to put one at the end, you'd have to fill in all that space with Fs to be the last usable address in the range. And to make it shorter, they make it the very first usable address in the range. And you can see we're pinging that now. All right, so first step's complete, right? We've got an interface with an IP address, and I can ping my gateway. So I'm at least getting local LAN connectivity. But to be able to do, out to the rest of the world, I'm going to need to set a static route. Which is only going to vary very slightly. Some level of pun intended there. Instead of the word route here, we're going to use the word route 6. And in fact, if you were to tap tab twice, you'd see that route 6 is one of the 2 options that is given here. And we just say route 6. Now, this is worthy of note. And a lot of operating systems use this nomenclature when you're setting up routes. ::0 is the same thing as 0.0.0.0/0. In determining the everything of the internet, right? If we say everything's 0/0, much like our v4 static route, which was, just a dotted decimal version of that, we're saying everything, which is how we set up a static route. A default route, which is a static route. And we give it a next hop statement, which will be the same thing, right? It'll be our the router that we've been pinging. this should let us do things like ping out to other places and other people and stuff like that. But knowing what their IP address is would be just crazy to try to write it all down and try to remember what it is. So most of the time we wind up using name servers because it's far, far, far easier. So we're going to set a name server, a DNS server, and it's quite literally the same command that we used before. And this is where it gets a little different. If you'll notice, all my other addresses at this point were 312. This one's 311, which means it's in a different network than my Voyos or the Voyos's gateway is. So to talk to the DNS server, it will have to go out through the local gateway at 312::1 and to be able to talk to 311::5, which is our name server. This is not unusual. When we do it in v4 land, we set whatever we're going to use for v4. You can use Google's, which are 8.8.8.8, but it'll have to go through the gateway to do name resolution. So that's not unusual. Just pointing it out here so that you know what we're doing. So we set a name server, commit, and we can in fact ping the name server by, we do a ping 6. And that would give us a good test of, is my default gateway set up correctly, because we have an IP address that's outside our network. And there we go, I can ping it. So that should mean that name resolution should work. So when we say things like ping 6, now you can see it's resolved it, but it's resolving it to a different address. So we are pinging via v6 here because we said ping 6. We can do things like traceroute 6. And we can see where it goes, and it'll give us all of our v6 along with name resolutions if they have them as it goes along. There are several other places that you can wind up pinging. We wind up pinging comma.net is a popular one in class. And if we had a web browser, we could go to it and see the little swimming fish. In v4 it doesn't move, and in v6 it swims. So maybe we'll take a look at that here. And you can see we can do, that was a v4 ping, and if we do a v6 ping, it'll resolve the name and ping via 6. So we can see it's pinging and pinging and pinging. It's a little bit different on Voyos to see the route table for v6. It's just show IPv6 route instead of show IP route, and it'll give us a route table. And we can see right here, this piece is our default route, ::/0. That's our default route. So we can see what that is, where it's going, what Ethernet card it's going out of, and if we had any other routes, we'd be able to see them in there. So earlier I said that I would show off a little bit more of what was going on this local machine, and I've got a terminal here that's I've got open. This is the local machine, so this is not in GNS3, but the host machine itself. And you can see above this, here, I'll clear that, and you can see my IPA, and you can see all my Ethernet cards. The one we're really looking at here is ENS192, which is here in the center, number 4, and you can see it's got several Ethernet addresses, IPv6 addresses. I've got a v4 address. It just says inet at 160.200, and that's statically assigned because I put it in. But here in the center, I've got 2 different public addresses at 2610A84831, and you can see they're quite long. And they're dynamically assigned by the gateway above me. It's configured to do what's called SLAC, which is a form of auto address configuration. It is similar in concept to DHCP, but is not always completely the same thing, as there's several different ways to hand out addresses or to auto-generate them. You can see down here at the bottom, I have an FE80 address, which is a link local address. It would be the address that I'd use when I want to talk to my neighbors that are in the same subnet with me, and I would use that to talk to my local neighbors as opposed to wanting to talk outside the subnet. All right, so one of the last things I'll show is some of the things in the browser. We've got other pings we can do, right? These are other places I know have a v6 address, and we looked at a few of them earlier. We do ping 6 net, right? They're going to ping, and we've done this in our hosts and that kind of thing. But what happens when we go to in a browser? Well, when we go to comma.net in a browser, when it's v6, you're going to get the little turtle here that swims. He is not animated in the V4 version, so I can't show you that, of course, because I don't have a V4 only browser. Browsers are dual stacked and have been for many, many years. But I can go and show you IP6 echo.net, which will show you your IPv4 address if you don't know it. If there were some reason you needed to know it, you could go there and it would spit it out at you, especially if you have a DHCP address or something like that. These would work, through Voyos or anything like that, but I wanted to just give a little overview on how that worked. I think that's it for this Tech Nugget. We'll be back with more, so stay tuned.